The cost for a ticket to the school play is a function of one's age, A, as given by the function below. The Belloc family attended the play. Mr. and Mrs. Belloc are in their 40s and have 3 children whose ages are 4, 6, and 12. How much should they have been charged? The key to this question is to understand that there's different costs depending on the age of the person that is attending. So when I look at this, Mr. and Mrs. Belloc are both in their 40s. So when I look at my function, from age 18 to infinity, it's going to cost them $10. And there's 2 of them, so it'll be 10 plus 10 for Mr. and Mrs. Belloc. Their 4-year-old child is going to lie within the 0 to 6 range, so that child's going to cost $2. The 6-year-old child is going to fall in this range because 6 is included in this interval, so it's going to be $4. And the 12-year-old child falls in the third piece of this, since 12 is included in this piece and not in this one, so will cost $6, meaning that overall the Belloc family is going to be charged $32 to attend the school play. This example asks us to sketch the graph of the following function. So our function is here and it has 3 pieces. The first thing I'm going to do is I'm going to draw a set of coordinate axes on my grid here. And then I'm going to label it. I'm going to make every box left to right equal to 0.5. So this will be 1, 2, 3, -1, -2, and -3. And up and down I'm going to follow the same scale, so every box will be worth 0.5 going up and down. Now, when I graph, I need to look at each step separately. So I'm going to look at this first step here. My graph is equal to 4 between -infinity and -1. So that means I'm going to have a horizontal line at y equals 4 from -infinity to -1 inclusive. So that means I'm going to include -1. So when I do this, I typically go to -1 and I go up to 4. Now, because it includes -1, I'm going to have a colored in dot. And then my graph is going to proceed to be drawn straight to the negative side here. Oh, it's not perfectly straight, that's okay. Oops. So that would be my first step. The second step is 2x plus 4 between -1 and 1. Now this is in the form of y equals mx plus b. So I can do this one of 2 ways. I can use my y equals mx plus b, or I can use a table of values. I'm going to use the y equals mx plus b. Positive 4 is going to be my y-intercept, which is going to fall between -1 and 1. So I'm going to plot that point right here. Then my slope is going to be 2. So I'm going to go up 2 and over 1. So 1, 2, and over 1. Keep in mind that the scale of your graph has to match your slope. Now, this point here I colored in and I shouldn't have. Should actually be an open circle because it does not actually include 1 at that point. And if I do the same thing in the opposite direction, so it'll be down 2 and over 1, I should have an open circle here as well. And then I'm going to connect my dots with a straight line. The last step is a quadratic. Now you can use your knowledge of quadratics from Pre-Calc 20, or you can use a table of values, which is what I'm going to do here. So I'm going to have my x and my y. Now I'm going to start at 1 because that's the first of our x values that's in this piece of the function. So I'm going to do 1, 2, 3, 4, 5, try and get a picture of what this looks like, and I'll plug each of these in to get our values. So 1 minus 3 is going to be negative 2, which squared is 4. 2 minus 3 is negative 1, squared is 1. 3 minus 3 is going to give me 0, and squared is 0. 4 minus 3 is 1, squared is 1. And 5 minus 3 is 2, and if I square that, I get 4. So this includes 1, so I can start by plotting the point 1, 4 with a closed dot. And then I can continue plotting my points to get an idea of what this graph looks like. So I have 2, 1, 3, 0, 4, and 1, and 5, and 4. And then I will connect the dots with as smooth a line as possible. And that is the third piece to my graph. This example asks us to find the formula for the piecewise function whose graph is shown below. So when we do that, we're going to look at each piece separately. It's important to note that there are 3 pieces. There is this first line, a second line, and then we have what looks like a parabola here. So I usually find it's useful to work from left to right, so I'm going to start by looking at this line here. Now, if this line had crossed the x-axis, it'd be easy to use the slope-intercept form to find it. However, it did not, so we're actually going to use the slope-point form of an equation in order to determine the equation of this line. So what I'm going to do is I'm going to pick a point on this graph. So let's pick this one here, for example. So this is the point -3 and 2. And I'm going to plug it into my equation. So y minus my y's value is 2 equals my slope. I'm going to calculate from here. So I'm going to go down 1, 2, 3 and over 1. So my slope will be -3 x minus a -3. From here, I'm going to simplify my equation as much as possible. So I'm going to have y minus 2 is equal to -3 times x plus 3. And I'm going to move my 2 over as well as distribute my -3 in. So I'm going to have y is equal to -3x minus 9 plus 2, which when simplified is y equals -3x minus 7. I also find it useful to take a moment to figure out what domain this is in. So this is going to be from -infinity up to -2. And I can include -2 and not infinity. The next piece that I'm going to look at is this line here, this middle line. This one does cross our x-axis, so we are actually able to, instead of using this formula, we can use our y equals mx plus b formula. So y is equal to my slope. So let's calculate from this point to this point here. So I'm going to go up 2 and over 1, so my slope is 2. X plus my y-intercept, which in this case is 3. So this is an equation in y equals form, so I can determine what my interval is. This is from -2 to +1. Now, I know it doesn't include +1 because it has this open circle, so I'm going to put a round bracket there. The -2 is a little tricky. It has a closed circle, but we've already included it in the first interval, so I cannot include it in both. So I'm going to use a rounded bracket here. Now you could have alternatively used a round bracket on the first one and a square one on the second, and it would have been equally as correct. Now for this last piece, the quadratic, we're actually going to go back to our Pre-Calc 30 knowledge as well as our Pre-Calc 20 knowledge of the equations of quadratics. And we are going to use our transformations and our knowledge of them to help us figure it out. So here is our base equation for a quadratic. And we're going to look at it in terms of a, b, h, and k. So when I look at my a and my b, those are stretches. And when I look at my graph, this has no stretches because it follows the general same pattern that a quadratic would normally follow. It goes over 1 and up 1, and then it goes over 2 and up 4. So I don't have an a and I don't have a b value, but I do have h and k values. In order to determine them, we're going to use the vertex of our parabola to determine how much it is moved. Now typically our vertex is at the origin at 0, 0. So to determine how far I've moved horizontally, I'm going to just count the boxes and see how far. So I've gone 1, 2 horizontally, so that means that my h value is going to be equal to 2. And to determine my k, I'll see how much I've gone vertically, so that's up 1. So my k value is 1. So I know that my equation then is y equals x minus 2, remember you always take the opposite sign, squared, plus 1. And this is from the interval of 1, which we're going to include, to infinity. Now, once I have those three equations, I can write this in my piecewise format. So I'm going to have that my equation, f of x, is equal to, now I'm going to have 3 steps, so I need to make sure I make my bracket large enough. The first step is going to be negative 3x minus 7. And that's for when x is between negative infinity and negative 2. Square bracket on the 2, round on the negative infinity. It's going to be equal to 2x plus 3 from negative 2 to 1, round bracket on both, and it'll be equal to x minus 2 squared plus 1 for 1 to positive infinity, including the 1, but not the infinity.